guys, this is Trevor here. Today we are going to talk about what's called the triangle inequality. Our learning target is you'll be able to determine whether or not three given lengths can make a triangle. You'll be able to find the minimum and maximum of the lengths of the third side of a triangle given the other two sides. You know you will be successful when you can find that the shorter two sides of a triangle sum to greater than the larger side. This sounds like a bunch of gobbledygook right now, but I promise I will straighten it out. We're going to look at our assignment from yesterday, check some notes for triangle inequality, and then try an assignment from the textbook. Let's jump in. Here are answers to yesterday's assignment. And the rest of them, this was the one with the probability. Make sure you're really trying those ones. It was the one from the deck of cards. All right, for today, here's what I want to do. There's a Decimus tool in section 231 and number 101A. I'd like you to try and then record your results. So take a minute here and pause and write this table I have below in your notebook. It's got sides, 3, 5, 10, 2, 4, 5, and so on. And then it's got a column for the shortest and middle side added up as well as the longest side. I'm going to do the first one with you. Let me first find that part in our textbook. It's section 231, 101A. So I've got section 231. And I'm going to go down to 101A. Here is the E-tool. When I open this, I see three different sliders where I can change the length of different sides of a triangle. Notice I've got side AB is here, BC is here, and AC is here. I'm going to go back to my slide and kind of go back and forth for a moment with you. Actually, let's see. I've got the first one is 3, 5, 10. So if I can pull that up, that'd be cool. Why isn't it letting me? There it goes. So 3, 5, 10. Okay, 3, 5, 10. I'm going to move these sliders to have 3, 5, and 10. And if you're having a hard time with the slider, you can just change the number. So there, we've got 3, 5, and 10. I'm going to zoom in a little bit. And our goal is to figure out if these can make a triangle. So let's move them around a little bit and see if I move these, oops, that changes the length. Let me make sure that sets to 3. So I just want to change the vertices. So if I try to move these around, is there any way this could make a triangle? I think not. So for this one, my shortest plus middle side, let's try. Shortest and middle would be 3 plus 5 is 8, and my longest side was 10, and this did not make a triangle. So I'm going to put yes or no out here if it makes a triangle or not. Try the next three and see what you can do. Say if it makes a triangle or not, and then note what the shortest plus middle side and the longest side for each is. Go ahead and pause your screen here to try those out. All right, let's see how you did. I have written in the two columns here that have the sum as well as the longest side. And let's see, your 2, 4, 5 triangle was a yes. This did make a triangle. The next one, 4, 9, 12, also made a triangle. And then the 3, 5, 8 one was kind of trippy. I want to show it to you because it kind of freaked me out a little bit when I looked at it. Here's my 3, 5, and 8, and I'm trying to move these things around to see if I can make a triangle out of them. And it kind of feels like I can get really close right here, but if you notice, I can zoom in here on the graph, and you can move around these vertices as much as you want, but they're never actually going to touch. They're super close though. So this one's still a no, even though it feels really close. Now let's notice the relationship that's happening here. The ones that were yeses are here and here. And let's compare what happened to the ones that were no's. So the no one, the shortest and middle side was less than the longest side, as well as on this one it was equal on the bottom. The middle two that worked, the shortest plus middle was greater than the longest side. 6 is bigger than 5, 13 is bigger than 12. That is going to be the name of the game here. So here's the deal. What is the longest possible side that could join these two? We're going to use the same E-tool, but it's on part C instead. So let me show you that E-tool one more time. This time I can X out here, hit leave, and I'm on part C. So scroll down a bit. Here's part C. Open this guy up. And it's saying, what is the longest possible side that can join these two to form a triangle, as well as the smallest possible side. So we've got 5 and 12 already preset for us. Actually, we don't yet. I'm going to set 5 and 12. And this one, we can use the slider to make it bigger or smaller. So I'm going to see what's the smallest side possible, and the longest side possible that you can make. You can change this number to whatever you'd like. Go ahead and pause the screen now to give it a shot. All right, let's see how we did. So if we have the shortest side possible, then that means that 5 and this side were the shortest. So 5 plus something has to be bigger than 12. That last number would have had to have been 8. So in this one, the shortest side possible was 8. If it's the longest side, then 5 plus 12 has to be bigger than that longest side. 5 plus 12 is 17, so 17 has to be bigger than it, so I would say 16 is the longest side. Hopefully we're starting to feel the trend here. Let's move forward and see what we can do with these triangles. So it says determine the minimum and maximum limits for each missing side in the triangles below. Let's see how this goes. The rule is that the small side plus the middle side have to be bigger than the longest side. That's the rule. So let's see, 3, 19, and something. Let's say 3 and 19 are the two smaller sides. Then 3 plus 19 have to be bigger than the biggest side. Well, 3 plus 19 is 32. So 32 has to be bigger than our side. That means it'd have to be 31. So the biggest side is 31. All right, now let's say that this side is our smallest side. So 13 plus our smallest side have to be bigger than 19. Well, 13 plus what will be bigger than 19? A little bit bigger than 19 is 20, so this would have to be a 7. So my smallest side would be 7. So this side can range anywhere between 7 and 31 units. On the next one, let's say that we are looking at our last side being the longest. That means 14 plus 15 are the smaller two, and they have to be bigger than our side. 14 plus 15 is 29, and 29 is just a little bit bigger than 28. So the biggest side will be 28 as the max. And then say this side was the shortest, then we'd have 14 plus it has to be bigger than 15. Well, I'd need to have a 2 there in order to make 16 be bigger than 15. So my smallest side is 2. Last one, A and B are here. Now, let's see. If we call this C, then we have this rule that A plus B has to be bigger than C. That's kind of our formula for triangle inequality. Let's wrap it all up. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So therefore, sides A plus B together have to be greater than C. Similarly, sides B plus C together have to be greater than A. And sides A plus C together have to be greater than B. All of these are true, and it's called an inequality because of the symbol that's used. Let's wrap things up with an assignment, and I'd like you to do it on graph paper if possible. So if you don't have any, keep in mind you can always stop up at the school and grab a set. I've got it in the office for you. If anybody ever needs some, the front office can take care of you and give you a stack of graph paper for the future. Section 231, pages 104 through 108, we've already been in there for most of today's lesson, so let's look at the rest of it. If we go down to the review preview, you'll notice 104 is asking you to draw a right triangle and then construct a square on the hypotenuse to find the square's area. Now, you haven't heard this terminology just yet, but it is right above in the right triangle vocabulary. We will specifically take notes on this next week, but there's a little preview for you. Number 105 says, an algebra topic you've reviewed is systems of equations. This is coming up to be a checkpoint problem in tomorrow's lesson. Here are two that you can try for yourself and then look at some questions to reflect on those problems. Number 106 is talking about a graph on the x-axis and how you can describe its triangle. Here's an angle problem with some parallel lines. And then lastly, one more, it's asking you to do it on graph paper, plot these points out and figure out what type of shape ABCD is. You'll have to think about the slopes of the sides. Give those all a shot, and if you have any questions, come see me on Zoom. Bye, guys.